We all love those tools, right? The ones that make our digital lives flow smoothly, you know, streamline those everyday tasks.
Hmm.
What happens when one of those tools, something we trust, turns out to be, well, a bit of a security nightmare?
That's the scary part, isn't it? That hidden risk in things we rely on. And it's a good reminder that even the most popular, helpful solutions can have weaknesses, especially in this interconnected world, right?
Absolutely. And that's what we're digging into today. This case with a GitHub action, DJ actions changed files.
Hmm.
It's not some obscure thing either. This was used by like 23,000 repositories, so huge potential impact, right?
Yeah, that number's a real eye-opener. Shows how interconnected everything is in software development. One small problem can spread really far.
Exactly. And that's why we're here. We want to break down what happened with this GitHub action, why it matters to everyone, even if you're not a coding whiz. And, most importantly, what can we learn from this to stay safer in this increasingly automated world?
For sure. Understanding how these attacks work and what to do about them, that's valuable for everyone. Helps us protect ourselves, our systems, all of that.
Totally. And before we dive in, got to mention our sponsor for this deep dive, Stonefly. They're the leaders in enterprise storage, backup, disaster recovery, AI storage, cloud solutions, the whole package. Looking for ransomware-proof storage? Stonefly's got you covered with their air-gapped and immutable solutions. Hit them up at sales@stonefly.com to schedule a demo. All right, so back to the topic at hand. Let's start with the basics. What exactly is this TGA Actions Changed Files thing? Why were so many developers using it?
Okay, so think of GitHub Actions like these little automated helpers in software projects. When a developer wants to, make changes to the code, they submit a pull request. And these actions, they kick in automatically to check stuff like, does the new code have errors? Does it build correctly? Things like that.
So it's all about making the process smoother, right? Less manual work, faster updates, all that good stuff.
Exactly. And TJ Actions changed files. This one had a very specific job. It would figure out, all right, which files have actually been changed in this new code. And that info, that's super useful for triggering other automated processes. Like you might only want to run certain tests or security scans on the parts that are actually new.
Ah, I see. Like a smart filter, making sure only the necessary checks happen. Makes sense why it was so popular. Saves time, resources, all that.
Totally. Streamline things beautifully. But here's where things take a bit of a dark turn.
Right. This is where it gets interesting and a little scary. The timeline starts on March 14th, 2025, around 4 p.m. UTC. That's when the trouble started. Malicious code, unauthorized changes were slipped in.
Yeah, and this code had a very specific and worrying purpose.
Hmm.
It was designed to steal, basically, CI/CD secrets from the runner-worker process, and then it would dump these secrets into the repository's logs.
Okay, hold on. We've talked about these automated processes, the CI/CD, continuous integration, continuous delivery. But what are these secrets exactly?
You can think of them like digital keys, credentials that those automated processes need to do their jobs. They could be API keys, passwords for databases, anything sensitive that's needed to build, test, deploy software updates automatically.
So if those secrets get into the wrong hands, well, that's bad news, right?
Yeah, really bad news. Someone with those secrets, they could take control of connected systems, deploy their own malicious software, access sensitive data, all sorts of nasty stuff. Like, imagine a compromised API key. Not only could they see the data, but they could change it, even delete it. And in some cases, these secrets might even give them access to other systems connected to that one. So it could cascade, like a chain reaction.
And the attackers in this case, they were pretty sneaky about it too, right? I read something about them updating multiple version tags of this GitHub action. What does that actually mean for people using it?
So it means they didn't just mess with the latest version. They went back and changed older versions too. Think of a version tag like a signpost pointing to a specific version of the code. The attackers, they moved those signposts to point to the bad versions. So anyone using any of those versions, they were unknowingly using the compromised one. It's like going back and tampering with the foundations of a building after people are already living in it.
That is a really insidious move. So once this activity was spotted, what happened? What did GitHub do about it?
Luckily, they acted pretty quickly. By March 15th, 2 p.m. UTC, they'd taken the action offline. And later that day, around 10 p.m. UTC, they'd cleaned up the repository, removed the malicious code, basically.
So fast response, that's good. But still, there was a window of vulnerability there. And I saw this incident got a CVE number, CVE 2025-300066. What's the significance of that?
A CVE, that's a common vulnerabilities and exposures identifier. It's a standard way to track security vulnerabilities, publicly recognized. Getting a CVE number means the security community thinks it's a big deal. It's a way of saying, hey, this is a known issue, we need to pay attention.
All right, so let's talk about how this compromise happened. I know a GitHub Personal Access Token, or PAT, was involved. What exactly are these PATs, and how did this one get compromised?
Okay, so a PIT, it's basically a digital key. It lets a user or an automated process like a bot interact with GitHub without needing to type in a username and password every time. Think of it like a temporary keycard. And in this case, a bot account named at TJ Actions bot, this bot had special access to make changes to the TJ Actions changed files repository, and somehow its PAT got compromised.
And that access, that's what let the attackers modify the code and mess with those version tags we talked about, right?
Exactly. The bot had permission to make those changes. But how that PA got compromised, that's still a bit of a mystery from what I've read. It's not uncommon, though, in these investigations. Finding that initial entry point, it can be really tough. Could have been phishing, tricking the bot owner into giving up the token, or maybe there was a vulnerability in the system where the bot was running. The fact that it's unclear, it just shows how complex and constantly evolving these security threats are.
It's definitely unsettling that we don't know for sure how they got in. Makes you wonder about all the other potential vulnerabilities out there.
Yeah.
So what was the actual impact of this? What could the attackers have done with those secrets they stole?
The biggest risk, the most immediate one, was the exposure of those CI/CD secrets. Because the malicious code, what it did was put this info right into the workflow logs. And these logs, they can be publicly accessible, especially for open source projects. So anyone who knew where to look could potentially grab those secrets.
Wow, publicly accessible logs. That sounds like a pretty big vulnerability in itself.
It is. It highlights how important it is to really think about who can see those logs, especially when they might contain sensitive stuff, even accidentally.
And I read something interesting about how the data was exposed. It wasn't like immediately sent off to some external server.
Right, that's an important detail. And a bit unusual. Instead of sending the stolen data straight to, like, an attacker server, this malicious code made it visible within GitHub itself. But it was hidden, kind of, through this process called double encoding in base 64.
Double encoded base 64.
Yeah.
So not immediately obvious, but someone with the know-how could decode it and get the secrets.
Exactly. It was a very thin layer of obfuscation, definitely not strong encryption. Wiz, a security firm that looked into this, they explained it pretty well. They said the compromised action basically injected bad code into any of those automated workflows using it. That code grabbed the secrets from the CI runner memory, the temporary memory of the system running the automation, and then boom, it's written into the logs. And since those logs can be public, the secrets were out there just hidden in plain sight.
So not like shouting, here are the passwords, but definitely exposed if you knew where to look. This whole thing really makes you question how much you can trust the tools you integrate into your workflows.
No doubt about it. It forces us to constantly reevaluate the security of even the most common, seemingly harmless tools we use.
For anyone who might have been using TJ Actions change files during that time, that window of compromise, what did GitHub recommend they do to protect themselves?
So there are a few key recommendations, and they're really important. Anyone who used the action between March 14th and 15th, first thing, they need to rotate any secrets they used during that time.
Rotate meaning like create brand new API keys, passwords, all that.
Exactly. Treat any secret used during that time as compromised and replace it with a new, strong one. It's crucial to limiting the damage.
Makes sense. What else did they advise?
They also said, go through your workflow logs, look carefully for anything strange in the changed file section. That could be a sign the malicious code ran and dumped those encoded secrets. You'd be looking for weird strings of characters, garbled text, things like that.
A little bit of digital detective work then.
Pretty much. And if any of their workflows were referencing that compromised version directly, using its commit SHA, they need to update that right away. Point it to a clean version. Using a compromised version is like, leaving the door wide open.
Right. And lastly, they recommended making sure they're using a tagged version of the action, like V35 or V44.5.1. Why is using a tagged version so important now?
So tagged versions, they're generally considered stable, well-defined releases. After something like this, the developers would make sure those tagged versions are clean and secure. Using one gives you more certainty about the code you're using. It's better than relying on a general pointer that might still be compromised.
Okay, those all seem like really practical and important steps. Now, zooming out a bit beyond this specific incident, what are the bigger lessons here? What did GitHub suggest for avoiding similar supply chain issues in the future?
They highlighted two main things. One, pinning GitHub Actions to specific commit hashes. Don't just rely on version tags.
Could you explain that a bit more? What's the difference, and why is the commit hash safer?
So a version tag, it's a convenient label, but it can be moved, like literally moved to point to different code, even malicious code, after the fact. We saw that in this attack. A commit hash, though, that's like a unique fingerprint for a specific version of the code at an exact moment. Once a commit's made, its hash never changes. Pinning your dependency to that hash, it's like saying, I want this exact version and nothing else. It can't be changed behind your back without you knowing.
Ah, so it's like guaranteeing you're using the real deal, the intended version.
Exactly, a much stronger guarantee of security. The second thing they recommended was using GitHub's allow listing feature for actions.
Allow listing, what's that all
Right.
about?
It lets you decide specifically which GitHub actions are allowed in your organization or your repository. You create a list of trusted actions and anything else is blocked. It helps prevent the use of malicious or compromised actions, shrinks that potential attack surface.
So it's like being proactive. You're saying, we only trust these specific tools.
Precisely. It's about staying in control, limiting those external dependencies in your software development. And speaking of control and security, you know who else is all about that? Stonefly. They're a leader in enterprise storage, backup, and disaster recovery, AI storage, and cloud solutions. If your organization needs top-notch security, they've got ransomware-proof storage solutions, air-gapped and immutable. You can reach them at sales@stonefly.com to schedule a demo. This GitHub incident, it really shows why that level of security is so important.
It really does. And it's not like this was an isolated incident either. There have been a bunch of reports about supply chain attacks happening around the same time, different parts of the software world getting targeted.
That's right. This GitHub thing, it's part of a bigger trend. Attackers are going after different stages of software development and delivery. We've seen stuff like the colors and faker NPM libraries. Those were deliberately sabotaged. Then you've got reports of North Korean hackers targeting NPM packages. The Silk Typhoon group, they're focused on IT supply chains. Then there's malware pretending to be DeepSeek AI tools. Even a tool connected to the solanapump.fun platform was compromised. It's a lot.
Yeah, it feels like we're hearing about these attacks more and more often these days.
Sadly, yeah. And they're getting more sophisticated. Attackers are figuring out that if they can compromise one popular tool, one library that's used everywhere, they can potentially get into tons of systems downstream. It's more efficient for them than going after individual targets one by one.
It is a bit worrying. Shows how even something small, a seemingly helpful tool, can become a big security risk if it's not properly secured.
Absolutely. It's a reminder that security has to be a priority at every stage for every piece of the software lifecycle.
So wrapping up, what's the key takeaway from this whole deep dive?
I'd say the main message is that these supply chain attacks, even if they're targeting something small, a developer tool, they can have huge consequences. This TJ Action Exchange Files incident, it shows what can happen when a trusted piece of the software process gets compromised. Sensitive information exposed, all that.
And those recommendations we discussed, rotating secrets, using commit hashes, allow listing, those aren't just for developers, are they? They speak to a bigger need for being careful, being proactive about security in general, how we manage all those digital things we rely on.
I totally agree. Those specific recommendations, yeah, they're for developers. But the core idea, verifying the integrity of the tools you use, minimizing risk from third-party stuff, that's relevant to everyone in all parts of our digital lives.
It really makes you think about how connected everything is. We're all about automation, efficiency, but how do we balance that with security? Especially with these sophisticated threats that are constantly evolving, how do we make sure the tools that are supposed to make our lives easier aren't actually creating vulnerabilities? It's a big question, and a really important one to think about as we navigate this digital world,